Hey, welcome back to TSS Garage. I'm Zach Chrisman. Today we're going to take a look at the Hofmann 7100 through 7800 series of weight class balancers. Today we're going to focus on the 72, 4, and 600 series, and let's take a look and see what they have to offer. Before we get going with talking about the machine, how it works, the user interface, I really want to dive into proper tooling selection and why it's important. I'm going to use this lighter passenger car wheel as an example. Generally speaking, we want to take a wheel assembly and we want to cone or collet it from the rear. It's not usually recommended to grab a machine interface from the front simply because that's not how it goes on the vehicle. If you can see inside of here, there's actually a machined lip that accepts the hubcap, and that's not the machine center line of the wheel. And that's one of the reasons we want to look out for that. The second, we want to deal with something that's low taper. Low taper allows us to ramp up to center much more quickly than something that's got a high taper to it, such as a standard cone. Standard cones can often lead to a slow ramp up speed, which allows two converging angles to get pinched off, if you will, before when too much torque is applied to the wheel before the wheel has hit the backrest or found center. This can often lead to a user chasing weight or wildly inaccurate centering of the wheel assembly and lead to someone questioning their results. So just make sure that we're using good practices here and using collets when necessary, possibly a pin plate instead of a pressure cup, and trying to apply those principles as often as we can. Okay, and moving over to the 7600P, you're going to notice first thing is we lose the keyboard. Everything here is going to be a touchscreen interface. Second, designation has changed from an S to an L and now a P. What is the P? The P stands for power clamp. And that's really the highlight of this machine. Not only does this machine allow us to integrate a power clamp to it in a 115 or 230 volt scenario, and you stepped up to the touchscreen, it's actually applying 90 pound-feet approximately of input shaft torque to whatever your tooling application is. The benefit there is a very even and a very precise application every time. So it keeps things a little bit more consistent. It's also extremely user-friendly. It's very easy to use, whether you're doing a small wheel assembly or a really large wheel assembly, a dually wheel, for example. It's got a lot of mass to it. Sometimes it takes a while to get those to ramp to center. So having that amount of leverage there helps in those applications big time. Again, we're gonna mount up our system using a speed plate. We have here an SRT Challenger wheel. We're gonna use a collet. We're gonna grab our wheel. You'll notice that the power clamp version has a sleeve on it. Grab our wheel. We're gonna get to the correct lug pattern. That's how easy it is to use the power clamp. We simply lift up on the foot pedal. It throws the clamp, and it has a couple of clutch mechanism wings that comes out, grabs the tooling, whether you're using standard sleeve with a bearing or a pressure cup. You still have those options. It makes things very nice. Again, we're going to take our safe arm, our semi-automatic parameter entry, and we're going to touch. You'll notice the backlight that comes on to help the user see. That's another feature. Looks really good. Close the hood. Touch, touch, close the hood. Super simple, very quick, very easy to navigate this machine. Once we get up to the touchscreen, I'm presented with a little bit more useful information. We touched on residual static imbalance on the previous machine. Here I'm actually being displayed that number right in the middle of the wheel assembly. So I can come over here and just touch the weight plane. You'll notice my wheel has spun and transitioned to the weight plane that I'm trying to add weight to. Again, have the laser pointer. The power clamp option denotes the fact that it's fully loaded. You're gonna have everything. So you have the laser and the power clamp. Apply my ½ ounce of weight, I can move to my next plane. Again, it's gonna stop on top. You may overspin or underspin a little bit. This depends on wheel's mass, of course, but it's gonna get you pretty close. I can look down, tell exactly that's fine, that looks good. I'm gonna apply my weights there. Let's go ahead and balance this wheel assembly and see what that looks like. It's asking me for 3/4 of an ounce. I'm gonna grab 3/4 of an ounce. I would recommend using scissors to cut your sticky weight. That way you're not peeling the adhesive or spreading the adhesive. It just looks a little bit cleaner for demonstration purposes here though. So you can see as I place this weight down here, I'm placing it at the edge of the laser and exactly in the middle of my weight. I can touch this again if I want to go to that stop on top position, or you can manually move it. We're gonna place our inner plane weight, and then we're gonna close our hood and perform our check spin. Now you'll notice everything has zeros and I'm being displayed in OK. If I was not being displayed in OK here, that means I have a residual leftover amount. That's what I was talking about in that previous machine. In that machine, we'd have to go back, F4, go into static mode, then hit F3, go to fine, and look at what that fine round off number is. Here it's saying we've trimmed down everything to less than 1/4 ounce. I can still select fine mode and look and see what the actual is. Because I have less than 1/4 ounce on my outside planes, the machine has determined that we're close enough. But what if I wanted to really get this wheel assembly down to the nitty-gritty? Well, by hitting fine mode, it's telling me that I'm 2/10 of an ounce still heavy on the outer plane. So I can put 1/4 ounce worth of residual static imbalance. So by touching that middle static plane and then hitting fine, I can now come back down and know exactly where to place another 1/4 ounce of weight. Once you know it, it's exactly where my outer plane was. You don't have to put it in that outer plane. You can put this weight dead center of the wheel if the application will allow it. I'd probably do it that way. In this application, I am just gonna dovetail it on the back of my outside plane weight stack. Now what that's doing is 1/4 ounce, of course, is closer to 2/10 of an ounce. But by rounding to the nearest quarter, you're eliminating the need to chase weight and place unnecessary weight on the vast majority of wheel and tire assemblies that are gonna throughput this machine. We're never gonna feel anything under 1/2 ounce, maybe even an ounce on an F250. But on this Challenger wheel and tire assembly, at high speeds, maybe, if we had a nice ZR tire on there, something like that, I'd probably make that determination based on overall diameter and vehicle application. I can go back now to my dynamic, perform another check spin, and you'll notice we'll still have zeros and an OK. And that's simply because we're within that area of round off. Now when I hit my fine mode, where I had 2/10 on my outside plane, now I have 5/100. That's a little better. This thing's ready to ship. So as you can see, 7600 offers us a little bit more user friendliness. So everybody in the shop can easily navigate this machine. The touchscreen user interface is super easy to deal with. You even have different users. You can set up different custom specs between users 1, users 2. You can switch, of course, just by touching the planes to nail on, sticky, that sort of thing. Very easy to deal with. It also has an element of match mount to it. Match mounting can be done by performing a check spin, twisting a tire 90, 180 degrees, and then the balancer is going to figure out where the lowest amount of weight required is on that wheel and tire assembly as you clock it or position it. That sums it up for today. Thanks for hanging. We'll catch you guys on the next one.